and this last one, especially not having one of her videos to help like walk me through it, kind of left me in a tight spot. So I would really personally benefit from having some of our time and attention geared toward that, but also like as Kelly is writing more and more questions into the doc, like I think that would kind of come after, for me personally, like I feel like I can find a research question after I've had a chance to look at the data to see what's going on.
Yep.
So
Kelly,
the first, go ahead. I'm sorry, what, Sandra?
pull up the screen and just like, I think like look at your variable view screen and just say like, this is what we're looking at. There's like 10 variables. This is how you know what they are. Like literally, right? So we've got, yeah, 11 variables, really not.
Yeah, we have 11 variables, but the other thing I want to make sure that has happened is I went ahead and copy and pasted the context into this doc that I shared with everybody. It's really important actually that you read this first. So has everyone read this first? And I don't even mind, since we're like together, I don't mind reading it out loud or having someone, but we're also like not in kindergarten. So if you just want to read it yourself.
Yeah. I think you're right, Kelly. I think we do need to all take a couple minutes to read it if you haven't, because it does make a difference.
And Dan, I know you're on your phone, so are you able to read it, or would it benefit if I read this out loud?
Sorry, I'm trying to find could you read out loud? Sorry.
I know what it's like being on a phone and like, I don't know, I have an 18-year-old and a 20-year-old, and they actually literally do homework assignments on their phone. And I'm not really sure how that happens because I can't do anything besides Instagram and Candy Crush. So context, the middle school data set includes a number of academic, programmatic, and background variables for the 6th grade students at Cactus Middle School. The academic variables include a language assessment at the end of year, and they give the label for it, which is Lang_post, and a pre-test, Lang pre, administered by the school district when students enrolled in the school. The district pre-test is equated to the state assessments, and the assessments can be compared directly. The state mean scores for the language assessments are as follows, and then it gives you what the scores are, which this is what we're going to find in the data, but it's like the pre-language 630 scale score points, and then it has in parentheses district average, and the range is 500 to 800. The post-language is 670 scale score points, which is the state average, and the range is 500 to 800. So the pre-test is the district average and the post is the state average. The school made available 2 language programs for students whose home language is not English. The first was an English as a second language model, ESL, where students were exposed to extensive instruction in English. The other program, dual language, included instruction in both English and Spanish with the intent of encouraging academic proficiency in both languages. It is important to note that not all eligible students participated in the programs. The student background characteristic variables include gender and race/ethnicity. In addition, the district gathered data on student mobility. The first mobility variable, which is years_district, measures the number of years the student has attended a school in the district. The second, start_school, captures whether or not the student started the school year at Cactus Middle School. According to the general findings in the academic literature, there is a positive relationship between the number of years in the same district and academic outcomes because the student has been exposed to a consistent curriculum. And students who attend the same school for the full academic year generally score higher on achievement tests. Put another way, mobile students generally score lower than students who remain in the same school for the full academic year. So that's the whole context. And then when we look at SPSS, that we were just looking at, as Sandra was saying, we see 11 different variables that were just kind of described to us in that context.
So when we go about running, like one of the things I thought about was just frequencies, like how many of what do we have? How many boys, how many girls, how many of everything? So you could run frequencies on, you know, most of these, not student ID, right? Or not school name, but on, and not on grade, because those three are constant pretty much, but race, gender.
So you're asking about like descriptive statistics, like you just want to run some descriptive statistics right now on like the data that we have. I don't know that I could do this like without whatever, but I can try. Is it frequencies?
No, it's just, well, I mean, descriptives will include that. Just go to descriptives, I think. I don't give it
Okay.
to you.
And
So
then
pick,
we now we want to see what we want to run it on. So you mentioned, now why is gender not in here?
go to the top. Probably because,
I think we have to, isn't this one of these where we have to make gender a numeric or something? Like we have to
You're
change.
right, because it's
Yeah, that's what I was
string.
thinking. The zeros and ones.
So we
Yeah.
have to change it.
Yep.
And so that's where we did that before. And I would have to go back to the homework to remember how to do that, because we did it on that assignment where it was like female 1 equals female, female 0 equals male. That was the exact thing that we did.
Yep.
what's that
But
called? Like recoding the
I
gender.
think, yeah, I think you have to go to values under gender, and then there should be 3 dots beside female, remember?
Yeah.
And then you change it to 0 and 1, whatever that might be for
You change
female.
the label or do you change the value?
The value, I believe.
Yeah. So
Yeah, try that.
Yeah,
So
0 and 1.
let's put 1.
Yeah.
But the other thing that I think we did was also we changed the name, because think about this just from like the perspective of a doing your just before I do this, before I change anything, I want to say like you could keep this gender string variable and we could, I feel like we made another one and then labeled it female, because if you keep it as the name gender and then you do 1 and 0, you're saying that gender equals 1. Like, do you see what I'm saying? Like you need to have it say female. Did we
Right.
not keep gender in the other data set as also a variable?
We did. I think we did. You're creating a new variable. You're just keeping that one there, just so you could use it for whatever else you might need it for, other things, I suppose. But then you just want to recreate it and make it.
I'm just looking at the other data set real quick because I want to compare it. So we kept the gender string. We created a numeric one called female. And that's the one that we put that way. But I guess I'm just trying to remember how we are making a variable based off of a variable.
Yeah. So you would go to.
Do you remember how we did that? Because I have to go back and look it up in the homework, like in the steps.
Let me just see something real fast.
Yeah, I don't remember how we did it.
I think it's transform. You could try it. I mean, there's
You're
nothing wrong with it. Try transform, recode into different variables. Try that.
Recode into different, Sandra?
Yeah, try that. Let's see what happens. So we're going to take gender and we're going to say.
You're right. This is how we did it. Output variable. So the output, we want it to be female, right?
Yeah, maybe. I don't know.
Label to be female, because that's how we did it. Female 1 and 0. The old value that equals F is going to now equal 1.
Right.
And then the old value for M is going to equal 0. Right?
Try it. I don't know.
I mean, I can go back and look. I'm just experimenting.
No. Try it. I have the numbers, so I could tell you what the frequency is. We're supposed to have 409 girls and 439 boys. So we could always see what happens.
All right, so now we have a variable that's
So
called,
go there. So now go up to, what do you call it? Frequency or
descriptive.
you could do that. Yeah. And then just pick
I
female.
mean, I
and
could
see
go to
what-
the data view. That's what you wanted to see, right? No, we don't want to see that. The data view shows us for female, but we
Go
don't.
up, go up to descriptive. Go back up to analyze, descriptive, frequency. And then pick female numeric. Is it not going to give it to you? Not going to give you a choice? Yeah. Female numeric. And then just go. There you go. So 0 is male, those boys, it's 439, and 1 is female, it's 409. So that's correct. So I did it right.
Does that make sense to everybody, what we did?
Frequencies are just like head counts. That's all.
Yes.
Right.
Kelly, can
So-
you go back to the assigning a new value, I got lost there real quick.
Yeah,
The assigning the new value?
Yeah, because I remember doing like I just don't remember what it was specifically.
So it's transform.
Yeah, so can I like just delete a variable then? Can you delete them?
We could try it.
It says clear. What does that do? It cleared it. Okay, so I'm going to go back to those steps again. So what we were initially doing, so Dan was telling me, Dan was right, by the way, like we could go in here under values for gender, and we could go in here and we could change these values here, potentially, maybe, I'm not really sure. But what I didn't want to do was because I knew on our other homework, when we did this, that we kept gender as it was, as like a type of string data, which is characters, letters, male and female. What we had done in one of our assignments was we transformed this specific variable and we named it female because, again, we're using the numeric coding of 1 equals female and 0 equals male, but you can't have like female/male. So like for this variable that we made, when it equals 1, that means it's female. If it equals 0, that means it's a male. And so in order to make that, we did transform and recode into different variables. And I'll move this back. Okay, so this is what it looked like. And the variable, it says input and output. So our input is gender.
Yep.
And what we want for an output, we want to create a value that's called female. And when we did this assignment before, the name and the label were exactly the same. It was female and female, and you have to click change in order for it to populate here. So the string variable is gender, and we are transforming it into this variable female, which is actually going to become a numeric. So in order for us to change it, we have to click on this old and new values button. We're still good?
Yep.
Okay. And then when we go to the old and new values, the old value, and this is because we looked up here under values and we see for gender that the value is actually F and M. Like when we were in that table, we saw that the value was F or M. So for the old value, oh, and they're already over here. So I'm going to remove them so that we can do it again. But the old value of F is now going to become 1 because we want it to be numeric. And once we type in old value and we type in new value, we click add. And then this little table shows us that the old value of F is now going to equal 1. And then we have to do the same thing for male. So the old value of M is now going to be 0, and we click add. We good still?
Yep.
Okay. And then we click continue. And then we're back here, and then we just click OK, and then it creates that for us.
why don't I have okay?
Hit change on the right. There you go. Yep. Now you got it.
You can label it there, Kelly. So you
Why does
could
it
put,
not show the labels though?
it won't give you, so now you put the value is 1. You could put value 0 equals male, value 1 equals female. Because it's just, that's what's going to help you when the charts come up.
but now it's putting it as, decimals.
That's weird.
Yeah, and I don't know if we did this part before.
Yeah, should see.
What I do want to do is I want to go back to, I just gonna keep comparing it to the old assignment that I knew. So
Yeah.
by the way, on this one, we never did do that part and never had it here.
No, we're smarter. We could do it.
I don't remember that part. I don't remember that part either.
Yeah, no, I was just playing around with it. I just put it in there just to play around.
But will it change anything if I do the, if I
Because
dump
it's
the,
doing it- Do you know how to get it without the decimal?
No, because the decimal is just here. Try it. Just see what it does there. Hold on. It's the same.
It just actually says male and female now, just like you said, because it didn't say that before. It said 1 and 0. So I'm good with that.
Yeah.
Yeah.
You see what we just did? Like, I just did that really quickly. It was like an experiment that we kind of did, and it works.
It's just the labeling so that you, because I personally, I'm like, what was one again? And I had to look at my papers and stuff like that. I hate that. It's so annoying
Well,
to
the
me.
reason it works for me is it's a computer science thing. It's like binary. It's like on and off, and it's just like how my brain is coded. But I like the fact that you can put those values in.
And we're sure that we have the values right, that it's 439 male and 409 female. Okay.
Yeah, because I ran a frequency just on the whole thing, and it said 409. You could do it like if you want to check, you can go up to gender. You can run a frequency on gender right there, like analyze frequency on just gender, not female, and you'll see it'll come up. I'll do the same thing for you. The only reason we went through that is because if you were to ever use in like a regression or an ANOVA or any inferential statistic, I don't think you can use string variable.
You're right. That's what it is. That's what, like, we were starting to do something and it wouldn't even show up. And I was like, why can we not get gender?
Right, because it was
Yes.
SM as opposed to 0, 1 or something like that. But like, we're just, yeah, it's like we're just playing around with it. But like, this is good if like we want to, for instance, as we get into this, right? If we decide, just as an example, the mobility variable, for instance, which is years in district, it's variable number 10.
Uh-huh.
The frequency for that, just because I pulled it, shows 5, 6 years. Year one, like 1 year, 2 years, 3 years, 4 years, 5 years, 6 years. So it's like, and it's almost evenly distributed. So it tells you that of all 800 and something students, there's a good breakdown. There's just like an average, like 50% of them have been there for 3 years or less, and 50% of them have been there for 5 years, 3 years or more. If any of our questions wanted to say something about that, and you only wanted to have one, like 2 groups or 3 groups, then you would reclassify it. If you wanted to look at all 6 groups, meaning those with 1 year versus those with 6 years and all in between, then you wouldn't have to touch that variable at all. That's weird. Yeah, no, that's right. What do you have there? So like it's a range, 1 year to 6 years. The mean average of years for students is 3.5. Right. And then if you did, I think it's, yeah, you could also see like mode and median if you picked it. Like you didn't check off the little boxes on that one, but you could try it again, you could see. So here, right? So under options, you could pick a bunch of other stuff if you wanted. That's it. Oh, yours didn't come out. Mine did. Let's see.
What did you do different?
Yeah, let me see. I did frequencies.
Because you went to statistics. You did frequencies and I actually did, yeah, so this is where I would have to do mean, median, mode.
So if you did frequency,
we could also do the quartiles.
Yep.
Which I'm not even touching because that hurts my brain right now, but
I mean, like 4 equal or 3 equal groups, right? If we know it's like 6 years, so we wanted to see 3 different groups.
And then put in your Standard
quartiles would be,
And
It's
okay.
4.
Yeah, quartiles is 4.
I like the cut points for 3 equal groups. That sounds kind of cool. Because you could
Okay.
try that.
All
And then
right.
wait,
Wait,
before you go, hit
standard
standard
deviation.
deviation. And then minimum and max. I don't know. Just see what it does.
Oh, I did gender.
Oh, yeah.
I was on the wrong thing.
It kept it all. So there you go. So you see the frequency is, it totals 848. So that shows you where all of these 848 students land in terms of years in the district. That's the bottom square that Kelly has there. But at the top, you see that the mean is 3.54, which is the average number of years in the district is 3.5. The median, which is the most popular year, number of years is 4.
It's 3. Oh, I see what you're saying. Median. I'm sorry. I was
Oh,
looking
wait.
at the bottom. I was looking at the
What's the difference again, median mode? This is such a bad question to be asking. I forgot.
One is like you take you like
Median
rank them, and then it's like the middle value.
Yeah, that's the most middle value is the median. The mode is the most popular one, I think.
Right.
It's like occurs most frequently. I think
Which
I
is-
want to do it a different way. I think I want to do it by actual quartiles. What I do remember us doing was like there was like more that we did with the quartiles where we like went in and we like named different things too. But I don't know that we want to do that. But I'm just curious what this one looks like now.
I don't see where that's showing up. Oh, I see on the bottom, percentiles.
Yeah, it's like
What
20,
time?
25th. We did something because it was like we wanted to see like the, 0 to 25 and then 26.
Yeah,
So what does that mean? Like 0 to 25%? I don't understand how to read 2, 4, 5. What does that mean?
I think it's, go ahead.
Oh, is that the average?
That's so
I get it.
75% of the group is in the district.
For 5 years.
5 years or more.
Yeah. Yep.
Does it even
that's
make
it.
sense though? Because if we actually add these up, 163 plus 108.
Yeah, if you add the next column, the percentages.
Oh, I see. 19.2 plus 12.7 is not 75. Like I'm not great at math, but I can tell you that much.
No, look at all the way to the right. Cumulative percent. You see we're 68%
Oh.
between. So it's between 4 and 5 years. So they're saying 75%, which would fall somewhere in between, have 5 years or less. It's not 5 years or more, Kyle. I think it's 5 years or less.
Okay.
Right.
Yeah.
Right. 5 years or less in the district.
That makes sense. That makes sense.
Or at least, let me say that. You say 5 years or less, or at least 5 years?
No, you'd have to say 5 years or less.
Yeah.
5 years or less. I don't know. I'm gonna probably stay away from this one, but that's for some
That's
of
fair.
us might want to look at like how, does the number of years when we get to the
I
question.
think in essence, if you really wanted to play around with this, right, you could say that only, 25% or less of these students are here for 2 years.
25%. Mm-hmm. And
Well, I think it's that you've potentially got 25% of your students that are only in the district for 2 years or less.
right.
Right, so if you're worried about, it's sort of that, and I feel like we did those percentages to try to break up the data, like if you really wanted to do the analysis around the point at which mobility hurts the language scores.
Yeah.
So you could do a percentage of saying, I just want to look, now that we know this, I just want to look at language scores for students that have been in the school district for 2 years or less and compare that with students who have been in there for 5 years or more. Like you could do that and see it, because that would be a way of getting at the mobility, because that's sort of like breaking down that data set for you instead of having to figure out what are the cutoff points.
And you can look at this table too and also say like only 12.7% of students are there for 6 years.
Right.
Because it's only 108 students. So that's only 12% of the full total.
So if could that turn into a question? Could you say, I'm tracking with this idea. I just couldn't figure out for myself like where to make a break, right, in the number of years. And so one way to say it is you could look at the mean performance of students with at least 5 years in the system. So that's basically 31% of them versus everyone else. Like that's just 2 groups. So that would be a t-test. Would that not?
Where are you getting the 31%? Because I see that there's 19% of students that are at the 5-year mark.
I said no, because I said at least 5 years. So that would include your 5 and your 6 years.
Okay.
So
yeah,
5.
I get what you're saying. Yeah. So you would create a variable for that grouping then.
Right.
What I would
And
think.
then
You would label them. You would label them like you're at least 5 years, and then you would create the grouping of the other people and
4 years or less.
the less years, and then you would run that t-test on that to compare, because you should be able to run and get the descriptive statistics of here is the mean pre and post test scores for this group of students. I guess what I'm curious about is grouping more than one of these together.
That's my yeah. That's why I didn't know, like, before you decide whether you want to do a t-test on 2 groups, you could do an ANOVA if you had 3 groups, if you broke it up into 3. The question is what tells us when we should care in this case about how to break it up? Because like Kamara just said, like we could look at by quartiles, or we could look at it by everything just so evenly split. I mean, they're not evenly split, but they're kind of like, it's not like half the population has been there less than a year.
Well, I think if it was me, and I mean, this is where we are our own scientists and our own like data scientists, where we're the ones coming up with these like thoughts and questions. But like, and it may look different for all of us, but I see the largest number at 3, the largest percentage is at the 3-year mark. It's like most of them are here at this 3-year mark. So I would be curious, since that's where like the median is here at 3, and the least of them are at 6, I would tend to be like, I'm curious what the comparison is here of this 3 and what the comparison is at the year 6. And like, that's where my brain would go. And I would be like, how much are they losing in their test scores by leaving at 3 versus staying all the way until 6? And then like, and it's like, well, what would you be like? Why would you care? Well, it's because like, is your intervention, if it's very statistically significant of a difference based on mobility, your intervention would be something based on keeping kids to stay in school, versus if it wasn't that statistically significant and you're showing that your ESL or your dual language was a better intervention, then you would put more resources into beefing up that intervention versus like coming up with another intervention. That's what I would do. Like, that's just where my head would go. And like, I think that's where my questions are, where I'm really actually more interested rather than mobility, because that like opens up a whole nother thing. I'm curious about comparing these 2 programs. I think like, I'm curious which one is more effective. Is it the dual language one, or is it the ESL one? And again, that's also influenced by who I am and like my background of like being interested in like what's given to kids curricular wise and everything.
I do think for purposes of what we're all doing together though, and then we could decide what we wanted to do, it would be interesting to run a t-test that gives us an idea about mobility, and then a t-test that gives us an idea about the language programs.
Yeah,
Let's
for
do
sure.
Right. And then to some degree, we all could decide from
Where we wanna
there
go.
what we decide to use in our analysis and where to go, but then we'd all, if you would, like, we would all have sort of everything we would need.
I think the language program one is easier because it's pretty one or the other, you know?
Yeah.
But like, let's finish this one and let's stay here because we're already
As
here.
long as we're.
So like, if you were to do a t-test on all 6, like, would you, this hurts my brain to even say, is that a MANOVA? I don't know. Like is that a Mankova? Not that I'd ever want to, but looking at the mean performance, like, is there statistically significant difference between the mean performance of students across all 6 years? Is that possible? Can you do that?
Question I have is, when I was watching her video, she said, she was telling us the steps to follow, and then she said, and then use my decision tree analysis that I gave you. So that's the, like, this is how you determine which test you're supposed to use. Where is
That's
that?
the one in the book. That's the one in
Oh,
the
it's
book.
in the book?
Yeah, wait, let me get it. Oh, wait.
I think we also had a handout to that end.
Does anybody know where? Because I'm like now starting to bookmark things that like I'm never going to remember, like effect size. Like, what is a small effect size? What is a medium? Like, I'm just not going to commit these things. Maybe I will.
It's all in the, yeah, it's in the book, but I'll tell you right now what page it's on. Sorry, I'm like walking like an old lady because I can't feel my legs. It's on walking like an old lady. Where is it? 178
178.
of this book.
178.
I see it. A quick but not always great approach to determining which statistical test to use.
Right.
Okay.
I mean, that's like, we're not using in this case. Actually, we could. Okay. Like when we think about independent, again, they're independent groups versus the dependent, which is like a pre-post. In that case, Kamara, you could say, let's look at all the students who took the ESL program. Let's look at their pre-language score and their post-language score and see if the difference between their pre and their post was statistically significant. That won't tell you that it's because of the ESL, but it's like a thing you can say. And then I'm just speaking slowly because my brain is going that slow. And then I'm like, you do the same thing for the other group, the DL, the dual language program. And you can say, was their pre and their post for the same students who were exposed to a totally different intervention, were their scores different?
Right. And that you can get from just running the descriptive.
And then
No.
compare those two together.
And then it's when you run the t-test that it tells you if that difference is significant, and therefore that's when you can start to say that it would be due to that program.
I'm not sure I follow you there, but let's try that. So you're saying,
Well,
if we,
okay, but I don't think we want to move away from the mobility here yet, right?
Right. Sorry.
So to me, we need to figure out what we would want to do with, we have to figure out what we want to do with that output from mobility. One of the things that I would want is first some descriptive statistics on these mobility folks.
Okay, so let's do
Like,
that.
what are their means on the pre-post tests? What are their, right? Because we don't really know anything about them right now, except how many have been in the district for how many years, but we don't know anything about their actual tests score.
So descriptive statistics on years in district variable. So Kelly, will you run that one?
Yeah. So would I do frequencies then?
No, descriptives. Or,
I think you do
oh yeah, frequencies, and then you pick all the stuff, right?
And so we want years in the district. and we want the pre-test,
Mhm.
and we want the post-test. And that's really it right now, right?
I think
Mm.
so. I mean, I would say let's run that.
I don't want to do any of these right now. I don't want to do this quartiles. I think we should just keep it straight for now. I can do the mean, median, and mode if we want. Do we think that that is valuable?
Yeah.
Yeah,
Okay. All right. So we're doing years in the district, pre-test and post-test. And that's just it right now.
Here. Wait a minute.
These are the old ones. Hold on. Let me do this. I'm going to close out I'm just going to clear the contents and I'm going to run this again so that all we're looking at is this. So we're looking at years in the district, pre-test, post-test. We wanted mean, median, and mode. We're not doing any of the percentile values.
So this is your frequency. Oh, there it is. That's it up there.
I feel like median and mode are like throw me off, I guess, but especially
We just need the mean.
Mhm. And the standard deviation.
Mhm. And we don't really need min max anymore because we sort of know it's 1 to 6.
Right. But Kelly, you see like underneath, like, did you want to see this for each year grouping, Kamara? Is that what you wanted to see?
I think that is what I wanted to see.
And I think that we need to go back and redo this analysis with descriptive, not with frequencies. It's going to give us what we want, I think. So try that again, because this is going to give us that long thing. Yeah, that's it.
I'm just going to close this out.
No, that's not it either.
See,
Wait a minute. Language pretest.
because what it's giving us is the range instead of each year, right?
Yeah, it's not correlating like
Not even.
it's not correlating the years to the test scores. That's what you want to see, right? You want to see like if the year ones, what is their pre and post test score? The year twos, what is their
right?
We're not seeing that. We're just seeing like we've just put like these are the years, these are the pre-scores, these are the post scores. We're not actually associating year two test score with doing descriptives. It doesn't give us that. We have to run something else in order for it to like assign if you're a year one, this is what you scored. If you're a year two, this is what you scored.
Right, and this is the mean of that. And then, yeah, because
Yeah.
that's what you really want to know, right?
Yes.
Would that?
Yeah, so I gotta think through this of like what we're
I'm gonna
trying
try ANOVA. Because I think when you do these, hold on, let me just try something. ANOVA, compare means one-way ANOVA.
Yeah.
Years in the district. Wait, what's the dependent? The dependent is the post. The factor is the years in the district. I don't know. I'm just gonna try something. Oh, no.
Got it.
Yeah, no, I don't think that's. How do you find that?
Hey, Chad, you got a minute?
See,
So, say hi to everybody.
Hi, everybody.
This is my husband Chad, who teaches statistics.
hi.
That's Sandra, and
Hi,
that's
Sandra.
Kelly.
Hi, Kelly.
That's Kyle. And Dan's in the airport.
Hey,
Um,
Dan.
I'm in the car. I'm in the car. I'm in the car now. So.
Oh, Dan's in the car now. Okay, so Chad, we want to run a test that gives us, so this is language tests, pre-post language tests in a middle school district,
Okay.
and we want to know by years in the district.
What do you mean by years?
So we have students
Yep.
who have anywhere from 1 to 6 years in the district.
Okay.
They've all taken a pre-language test and a post-language test.
Okay.
We want to know by years in the district what their mean score is on that language test. So so for all the students who have been in the district 6 years, their mean
Yeah.
score on the test is this. For one, it's this. What test would you run to do that?
I almost feel like you're trying to look at you're looking at is there a difference based on number of years, right?
Correct.
Yes.
Yeah, it almost sounds like a chi-square, but what are
I
you comparing it against? Like what's your expected versus the actual?
I have no idea what you are saying right now.
Well,
I mean,
so
I understand the words.
Does-
but-
Not so much, well, it's comparing it to one another.
or compare it to one
One
another.
another.
Yeah, we're
Right.
comparing-
Right.
we wanna see if there's a correlation, if you will, to the
A
number of years
correlation,
in the
right.
district to the higher. the
So
score.
is it a Pearson's correlation that we're trying to run?
You just want to know means right now. We're not trying to see if they're significantly different from each other.
So you're just doing
We're
mean
just-
by year?
Yeah.
You're just doing mean by year.
Right. That's all we want is mean by year. And it's
Not
like
sure
for
how to
some
do that.
Maybe that is
trying to
what
see.
it says.
That's why you don't use statistical software. You just plug your calculator and take 4 numbers together and divide by 4.
489 students. We are not taking out our calculator.
Can you filter by year or can you?
We can run and see the number of students per year. We just can't see what those test scores are. And we can also run and see what the median pre-test score is and what the median post-test score is. We can do all of those. We just can't get an association between what the year one's test scores are.
I'm thinking we have to do something with the value in the years in the district.
I was thinking we needed to create a variable for each year, which seems really tedious, but like if we were to create a variable called Y1, and that was a variable that was like we did with male, female, because we only had 2 there. If we created a Y1 variable, a Y2 variable, a Y3 variable, if we had a variable for each year in the software, then we would be able to run it off of one variable and say, you
Yeah.
know, that's where my head was going, was what I was thinking.
Is that what we did with those percentiles the last time?
I think we tried to, but that was more around, it wasn't based on years, it was based on actual like quartiles of performance. So it was like the top 25 performers are in here and the top, and you can just do that just with like a median score because there's no other variable. You're just chunking your output into like percentages. But for
Kelly, try
ahead.
1 year. Just try year 1. Just like,
Okay.
so you take
That works.
years district, which is 10.
And I would transform it, right?
Transform it into a new variable or
Recode into
recruit.
different variables. So yeah, we're just gonna try this. So we take years in the district
Mhm.
Right, clear everything out.
and our output variable, we'll call it Y1 and the label can be Y1.
Mhm.
And then old and new values. So what I have to figure out though is, see, that's where this is confusing because it says no values here.
No. But it's one, I could see it in the frequency output. It's 1, 2, 3, 4, 5, 6. That's exactly what it says. So just go, if you go to old and new values, and then old value is 1, new value is 1. Will it accept that?
But we're not changing anything.
You're just creating a whole new value though. That's only that. It's only going to be the 100 and
I get what you're
student.
saying. Yeah, no, I get what you're saying. The old value is 1, the new value is 1.
That's it. And then just close it. Right. See what it does.
And so we would need to run the statistics on this to see what it says to check it. So we would just run descriptive. We just want frequencies right now. And we're trying to come up with that number that it actually is, which is what, like 113 or something? I don't even know what it is. Right?
Yeah, it's 117.
And we don't need all of this. We don't, there is no mean, like there's just a number.
Right. Oh no, there is a mean because you got to get the other thing. You got to get the pre and post. Remember?
Well, right now I just want to see if this even worked. If I
Okay.
run this and it shows me, I just want to see if it gives me the number. Because if it says some weird number, it doesn't even, our
Right.
logic is flawed.
Is there? There it is. 117. So
Okay, so now then we could do what you said. We should be able to go in and we should be able to run the
but you
same.
know what? Why wouldn't you be able to do all of them? On that same Y1,
Okay. So you want me to do like, well, then I wouldn't call it Y1. I would call it something else. I would call it like divided, or I would call it like years broken up, or that's a terrible name. What would you call it?
Well, you just could, I mean, what would we call it that's different enough from years underscore district?
just leave it as Y1 for now. We just know that's our
Just leave it as
experimental one.
Y1 and we'll know everything under there is.
Yeah, just for now. But I just want to see because you know how you put old value, new value. So what if you did that 1, 2, 3,
Do 2, 2, 3,
Yeah.
3, right?
Yeah, that's what I'm thinking. Like then I don't understand what the difference is and why it won't just do it.
I can, but do you want to just run it one time just to see if we actually get correlated test scores before we add in all 5 and then,
I would do that.
Yeah.
The test scores.
and I also keep forgetting if I'm supposed to be using frequencies or descriptives. I we want frequencies, right?
Yes.
Cause that gets us the mean and
Yeah.
And so we want the
The pre and post.
pre-score and the post score.
Yeah.
And then now we can ask for that. I don't really want to do mode if that's okay. Do you want minimum and maximum? Or do you just want to run this and just see what happens?
Run it.
Let's just see what happens.
Is this a new one or is this an old output?
This is the new one now. So for the pre-test, it's what was the pre-test before the huh?
See in a second.
yeah, we just have to get rid
It
of it.
was 632.13.
So we're not getting it based off of this year 1 at all. It's still not doing what we want. It's just still telling us the mean of the pretest. It's not telling us the mean of the pretest for year 1.
Oh yeah, I see what you're saying. Because what Kelly's saying is the mean there, which is 632 and 673. Those are the exact same means for the whole 800 students. So it didn't disaggregate it, which is what we're at. I don't.
I think we have to go back to an old assignment. Or skip this. It just feels like this is something we should know how to do, but
It does.
so,
This is one with tutor.
yeah, I didn't pull anything for year one.
And what it's showing us here is it's also telling us like for this specific score, like the frequency of like how many people scored that specific score. So we've got all the different scores, but within this table, there's nothing that we need a column that says years, like years there. Like we need to be able to see how do years in the district affect your pre and post test scores? Like, how do you run a test for that? Because we know we could do it for female and male, like based on our homework. We know that we have that data and we could
Did we try this based on that variable?
for female and male.
No,
Um,
I don't think we did.
we'd have to go back to the last homework, which to do that, that's a t-test in order to figure that information out. Remember, that wasn't just descriptives. Wasn't that a t-test?
No,
For
you could do it. You could do descriptives, no?
Well, let's see here. This is the homework. Compare the following on both A and B, males versus females. Analyze, compare. No, it's an independent sample t-test in order to correlate that exam for males and that exam for females. That's a t-test. So I don't know that.
So that's why I'm thinking it was an ANOVA, because when you pull it, a means, so an independent sample, a dependent sample test, those are always comparing means. That's all that is. Just, does this mean look statistically, is it statistically significant? All that matters is the difference is how many groups you're looking across, right? So with an independent t-test, each of those groupings are different from one another. It's not the same group of students, which is what we're looking at here. The kids in group 1, which is year 1, are not the same as the kids in group 6, which is year 6. So that's why I think it's an ANOVA. And that's what I was trying to look at, because when you pull these tests, it would automatically give you the mean and the mean. But for some reason, it didn't do it for me. So I don't know, maybe you want to pull an ANOVA and see if it comes out for you there. Kelly, while I'm looking it up in this
Never
book.
done an ANOVA and I don't know how to do it, but
No,
why would the male and female, because those are two different groups, why would that logic not work? Because
Right.
the males and the females are two different groups
And
that
if
we were trying to compare. Oh my gosh, I'm sorry. My dog just farted and it goes, get out of here. Come on, now move. It is so disgusting. I'm going to die. Get out. Come on.
did
No.
she say we put it on a male female?
No.
She's wondering why we'd have to go to ANOVA like you're suggesting, and why can't we just do a t-test?
Well, for female male, you do a regular independent t-test, but if you're going to do years in the district, it's
Let's
an
just
ANOVA.
pretend there was only year 1 and year 2. What is the difference between male and female and the difference between year 1 and year 2? Those are also two different groups, and males and females are also two different groups. Can you get her out of here? She's
When you pull that variable, it's pulling in all 6 groups. There's 6 values to that variable versus there's only 2 values to the other variable. I'm just looking at this chart, and this chart says, this is the question. I'm examining differences between groups of 1 or more variables. In our case, it's just 1. Are the same participants being tested more than once? No. How many groups are you dealing with? More than 2 groups? Then you do a simple analysis of variance.
I see what I get it. I get what you're reading.
When you compare means for more than 2 groups, analysis of variance is a procedure to use.
I see it. Yeah, I just don't know how to do it, but I'll
Here, just
feel
go
like
there and I'll
I feel like this was the one that we didn't do, but
I've got the whole SPSS. It says, get in there, go to the one-way ANOVA dialog box.
where is it?
It's under compare means. one-way ANOVA, right? Okay, then it says, click on the variable named group and then move it to the factor box. Let's see. In our case, it would be years in the district. Yeah, years in the district is our factor.
Okay.
Yeah.
Didn't you just run this and you said that, or you said that's the factor? What is the dependent list?
And make that post.
The dependent is post. And the factor then is the years in the district.
And then click options. I don't see how, oh yeah, and then descriptive. And then continue. And then okay. Boom, there it is.
Boom,
Yeah.
Sandra.
The win.
There it
Great
is.
job.
Dan, thanks for the moral support.
That's all I can do right now. I'm like,
We'll take
I was
it.
lost in the ANOVA.
Thanks, Chad.
Thank you, Sandra, I had to go back and read that chart, and I read exactly where you read, but I thought you said you ran it and it didn't come out for you. Did it come out for you?
Why? Because I put two different variables in the dependent as opposed to just post. I don't know. I guess I wonder if we have to do pre, like you would do pre by itself. You do post by itself.
And then would we have to do something to compare those two? Like, are we able to?
Oh, I see what you're saying. Oh.
Like, are you able to do it that way? But like, let's just go with this right now because this is exciting.
This is not telling us what we're wanting. Like, I think what Kamara wanted to see was like, if you look.
This is really interesting. I'm sorry. The people that are in year 5 actually scored higher than those that stayed for 6 years. So just to like what I was saying, if I was like evaluating this, because you were like, well, what's the year that they fall off? Well, obviously it doesn't, just looking at the mean numbers, like it doesn't seem like there's any benefit to staying 6 years. But from like year 3, like if we wanted to compare year 3 to year 6, I mean, 11 points is pretty significant.
4 to 5. That's an 11.
Can I ask you guys a question? Because this is what I get super confused on the standard deviations. Talk to me about what this is saying to us, because I'm not. This is what I always struggle.
So on 117 people, the mean score is 660, but the standard deviation means that between all of those 117 people, that there is an average of like 43 points either on either side of the mean. That is, so like on average, people could score either 43 points lower or 43 points higher. Like that's a pretty high standard deviation. Like it shows. Go ahead. What were you saying?
Yeah, I mean, Kyle, what are you saying, Kyle?
I was saying they're all pretty significant if that's what you're going off of. I mean, to go even in the sixth year, like to have 31 point swing high or low of that.
I mean, is that just like, how do we know that 30 points is a lot? I mean, I know 30 is not as much as 48. I get that, which is an interesting thing, but 30 points.
That's another question that I had. And when I was reading our the exemplar for assignment 3, I can tell you that the standard deviation, because I just remember it was 11 points on that one. And that scale, the minimum is a 0, and the maximum of that score test we were looking at was like 200 or something. And I personally didn't think 11 was very significant, but I guess just mathematically speaking, if you kind of like look at the minimum and the maximum points available on the score, I don't know that there's a mathematical calculation that says if you are within this percentage of like your available points, this is what tells you it's significant. But yeah, 43 based off of a score of and that goes up to the 600s. I can't remember what they said the highest was. I think it was like 800. It does seem kind of significant. Versus if all of those were in the 10s, to me, that wouldn't seem that significant. Like you would expect kids to score 10 points higher or lower on some sort of a test, but 30 or 45 or 48, Like that seems pretty significant to me. But again, this is just like logical in my head, like thinking about numbers, or I'm not using any sort of mathematical formula of like, oh, this is the actual percentage.
Isn't that what the between group significance is telling us below?
Yeah, so that's saying, and I'm reading it right now, because what we're looking for is the between group significant, not the within group.
Right.
That it is statistically significant at 0.001. But I don't know what group it's like between all the groups, between some of the groups. So here it says, okay, ready. The obtained value is among the mean of three groups. Okay, the obtained value and the critical that the three groups are different from one another without concern for where the difference lies. So I guess this means like all six. Okay, hold on, I'm sorry. If the obtained value is more extreme than the critical value, the null hypothesis should not be accepted. Ugh. Is this when I have to go back to the book and look at the critical value somewhere?
I don't think so.
No, right?
The other thing that I'm noticing here, when I pointed out the first thing that stood out to me was how high year 5 was. I also see that the standard deviation is the highest for that group. What that would flag me is that there's an outlier in there somewhere. So somebody scored just significantly higher in that group, which would cause the standard deviation to go up higher, and it would cause that mean score to go up higher as well. So like there's just an outlier probably in that data there.
And conversely, the standard deviation was the lowest in the 6th year.
Yeah,
Say that.
you're right. So you
That's
could say that it's like more stable.
Yeah.
He was saying that the standard deviation is the lowest in the 6th year. Like in test scores, ideally you kind of want as low of a standard deviation as possible. Like you want all the kids to be like learning equally. The higher your standard deviation is, that means you got potentially some kid learning way more and some kid potentially learning way less.
Well, yeah, because look at your year 6 min score.
It's considerably higher.
It's
It's
607.
high.
Yeah.
It's the highest.
Mhm.
So they are on average higher performing.
Yep.
Yes.
Yep.
What you were saying though earlier, is that like, is there a difference between the beginning and the end, like the pre and the post, for each group? So like, let's just say like,
Right.
Is this what we need to do?
if you were a year 1 student, maybe we would assume like there's not much difference between a pre and a post. But if you're a year 4 student, there might be a difference. But I don't know if that's a question I would ask either anymore, now that I'm looking at it like this.
I mean,
So let's go back and do the ANOVA for the pretest and see what those scores look like.
Yeah. Okay, let's do that.
oh no, not at all. You did not coming off.
Everything else stays the same.
Yeah.
All right, so this is our
It's significant.
post-test. This is the pre-test here.
Oh,
It's interesting that we still have, even in the pre-test, the year 5 scoring higher, and we still have like the same standard deviations, even in the pre-test. Like,
Yeah.
it's almost like whatever that condition is exists regardless of the intervention. But we also have to consider at year 5, that intervention has been going on for 5 years. Like, it's not like it's, like, yes, it's a pretest, but it's a pretest at year 5 of everything they've been doing at year 5. So that's like why, well, I'm really curious now as to like, what is the performance like this is also hurting my brain, but I'm like, what is the performance of year 5 students that took ESL pre and post versus what is the performance of the year 5 students that took the dual language model pre and post? And again, now I'm going back to like comparing what those two different programs had as far as a factor. But like we all assume that years in the district, and they even made a claim to it within our context, that years in the district affects how well you're going to do.
Right.
I just find it interesting that like between year 5 and 6, there's somehow this anomaly of like the year 5s are performing better than the year 6s.
Well, better,
Score wise mean like better mean score.
I'm just looking at the number of amount of students in there from 163 to 108 too. Did that have anything to do with it as well?
I
You mean
mean,
and
The,
it
the
should
number, the number of people.
students.
Yeah, the
because
number of students.
when you calculate an average, the more you have, like the less
Yeah,
it's going to, the less an outlier on either side is going to like affect your average, versus when your number goes smaller, particularly outliers on the low end are going to bring your average down a lot more. And you're right, it's like almost, it's not quite double, but it's like it's significantly
yeah,
more
it's a
students.
significant amount. Yeah, or less.
Right.
right. That's why I think looking at the min-max scores just gets to be so interesting, or the lower and upper bound scores.
Yeah, and then you see that like really high max score there on that year 5.
No. Well, I think like anything else, right? Like even in the previous assignments we did, you can make some assumptions based on this. You just don't know 100% for sure, right? And that would be part of what we would be writing up. Like if I got these results, like Kelly, for you, right? Like if you got these results, you'd want to do the following, right? And that's what you could write up without making any definitive statements.
Yeah, I agree.
Now, yeah, I'm just wondering about the correlation, and I think it doesn't matter.
Yeah, that's a different.
Yeah.
Correlation between what and what? Between mobility and
Test scores, right?
I mean, that's what we're looking at right now, aren't we? Is the correlation between mobility and test scores. We're looking and saying, if you're there for 1 year, the average score is this. Whatever correlation you can draw from that is like what you were saying is.
I don't think, but I'm happy to have you all tell me that I'm wrong. I don't think we're actually looking at whether or not they're correlated. We're just looking at their scores, and we can't say if they're correlated or not. So you'd have to run like a Pearson correlation to tell us that the two things are actually correlated.
Right. So that would be a Pearson.
Right.
Right. So if let's say we wanted to do that. The question though is when. All right, so we could do that. Do you want to go there? Analyze, correlate, bivariate.
Because I think that's the only way we could say that mobility matters. You can wonder based on this.
So we would do years in the district, and we would do post-test. Is that all we want to do right now? Or do we want to do pre-test and post-test?
I don't know.
I think just post, right? Because ultimately Years in district and how they perform on the test.
Yes.
But as I was saying, like, if you think about the pretest, when you're looking at a year 5, that pretest result you get for a year 5, it's going to be associated to the fact that they've been in the district for 5 years.
So Pearson's would tell us whether or not that's just by chance or whether or not they're truly correlated.
Right. It's going to tell you.
Get at sort of your idea, Kelly, of are there 3 or 4 students in there that have outlier scores that are pushing it up that makes it look like year 5 is a difference, or are they actually correlated? I think the correlation theoretically cuts through that noise.
I agree. Do we want anything else on these options? Do we want these means and standard deviations?
I think so.
Yeah, we do.
I don't think we want this because I don't know what that is.
I don't know what it is. Let's not do it.
Let's see what happens. Do we want two-tailed or one-tailed? And actually, that's one of my questions. What is the difference between one-tailed and two-tailed? I don't actually know.
It has to do with direction, and I don't understand it.
I don't either.
Does
Just leave it
anybody
like
understand it?
I do.
Not
I do
today.
not. I did it wrong last time on the assignment.
Feel like we want a one-tail, but
I think so too. I feel like two-tailed is going to give us a bell curve that we're not going to want to look at.
on a one-tail. I think we want to know if years in the district is impacting language scores.
it's like if one variable goes up, does the other one go up with it? If
Right.
one goes down, does the other one go down? That's all
Correct.
it's telling you. It's not causation, right?
Right.
Correct.
Here we go.
Good Lord. Okay. Years in the district. 0.001. I'm looking at my thingamajig here to see what it's supposed to tell us. Remember that it's -1 to 1. Oh, it's the same. Okay, it's the same thing. So it's saying that the 2 are positively correlated. 0.202 though. That's the 0.2 is weak. Oh, look, the size of the interpreting a correlation coefficient. 0 to 0.1 is weak or no relationship. 0.2 is weak to moderate relationship. How can you have something that is
Well,
weak?
it's all like your level of confidence that you could say it's correlated, right? So moderate would say it does appear that there is some correlation between years in district and performance on the scores. There may be some other factors as well because it's not as strong as we would like, but it does appear that there is some influence there. I would think that's what we could say.
I just don't understand then the significance though. Maybe we're not supposed to look at the significance.
Well, you can. I mean, it's that there is a statistically significant.
Oh, it's saying that the correlation is significant means that the relationship is not due to chance.
Right.
Yeah.
And they did a two-tailed, but that doesn't matter. You could try it with a two-tailed and see if that
Nailed and
changes.
see what it does. Just curious to know what I'm struggling that we only have year 1 up here and we didn't get a true Pearson's correlation table.
That's what I'm struggling with. And I'm trying to figure out like, why did it do it that way?
We've gotten that full table that shows the year 1, 2, 3, 4, 5, 6, and then the correlation, because then you could see
I agree.
that year 5 that you're talking about, Kelly.
Agree. And so how do we do that? And why did it do it that way? The two-tailed showed up exactly the same as the one-tailed.
So what?
I think because they have to be independent variables. They can't be values of one variable. So maybe that we have to break them up like we were trying to do at the beginning, where you have like a variable that is students with 1 year, students with 2 years, students with 3 years, 4 years, 5 years, 6 years, and then you would put them in there all of them, along with years in the district.
So would we
But
would we break them up the way we were doing by transforming that years in the district? And
Oh, and then the question would be, can we do it all in the same variable that like Sandra was suggesting?
we can, I don't know how to edit this one, so I'm really just gonna clear it and I'm gonna go back and start over. So I would go to years in the district, I would go to transform, recode into different variables, right?
Hmm?
And we're gonna name this,
oh, you're gonna put them all in this one?
yeah, that's what we're gonna try anyway.
Years, capital or something, I don't know.
And then for old and new values, the value of 1 is year 1. Is that what their values actually are?
Yeah,
2,
1
3,
and 1.
6, yeah.
Well, I can only, okay, 1 and, all right, it's fussing at me. All right, I've already done that. So we just are just doing 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, like that. All right, I didn't run anything. It just pulled up the viewer. So now we have this variable that's years that we hope would break it out. So if we went back and did our bivariate, and instead of using this value, we use
Years. It's at the bottom.
this one. I didn't know you could drag that, but for whatever reason, I wanted that one on top. And just try it again.
See?
That did not do
No
anything.
luck.
That's a good thought. It's the exact same result as before.
How frustrating.
I was gonna try to go back in our assignments to where we did this.
When did we do this? Like what do you remember us doing this? I don't.
I
We did.
remember the quartiles is what I remember, I guess, where we like output information based off of like 4 different quartiles.
M8? Is it M8 or M5?
What's that?
M8 or M5? It's like the first assignment or the second one? The second one, the second assignment, which is M8, is when we did the correlation, Pearson correlation. It was all two-tailed,
Okay,
and there were not values to these variables. They were just numbers. It was 10th grade reading math, 10th grade math score, 10th grade reading score, 10th grade GPA. That's all it was. So see those values, those variables rather, those variables are, what are the 4 types? Nominal, ordinal, interval, ratio. I don't know. They're like the most complicated ones because you could have on the 10th grade math score, it's like between, you know,
Wait,
200 and, sorry, go ahead.
I'm looking at assignment 2, and there was something we did where we split the file, where we did organize output by groups. And I'm looking at this like data split file. And so like that's another option for us, but I'm trying to figure out, because we don't have a variable for each year. But if we had a variable for each year, we could split our data and split the file and run descriptive statistics for specific variables based on a split data file.
Right. So we split the file by math class enrollment, remember, or female, male. maybe we should just go to data split file.
But we just don't have
And-
variables to split them by right now is what I'm saying. Like the
Oh.
variable we would want to split it by.
Years, couldn't we do years in district?
No, you do years in district. So clear all that again for a second, or maybe just keep adding to it. It's fine.
I think I'll keep adding to this one just in case, because we've got a lot that's
Yeah.
that is mostly worked at the top of this one. And so I'll just keep adding. So, all right. So we want to
Split
try
file.
to split data.
Yeah, data, split file,
Well, mhm.
and then
Years.
years. Well, years, or where did our other one go?
We can
Where did,
only split nominal variables.
we can only split nominal variables?
That's all that's showing up in here is nominal. I'm just looking at them.
Yours is not nominal.
This year's is nominal. We created it. We
That's what I'm
created
saying.
a nominal variable for the years. This is our years that we created. The other years is not. This year's is.
I don't understand what you just said. That's not, that's numeric. Oh,
The same number.
what does that mean? Good grief.
Right.
Hold on.
Yeah, so you've got different. Okay, you wanna try it?
What do you mean?
What you just did?
Yeah.
All right, Kyle did something over here.
all right.
Well, so yeah, so I split the file
Okay.
by,
By the value that we created.
no, years in the district.
I don't have that as an option.
Did you do it by the new value or the old value years in the district? You didn't create the new one that she
They
created.
did, I didn't
Okay.
use it at all.
Okay,
Because that's my only option is to use the new one. The old one is not showing up.
Okay, can you cancel out of, like, I don't. That looks different from what I did,
data split file.
okay? There we
There
go.
you go.
Now do years in the district. Yep, and then hit okay.
And then
See
we
what
haven't-
it-
we haven't run anything yet. This is just telling our SPSS that anything we run now is going to organize the output by
Yep,
groups.
right, so now go back and do the bivariate. Or the correlate that, and then take the years out, years in the district in. And then run it. Does that get us what we needed to?
It's,
Or is it really the same thing?
It's giving them to you. We just then have to.
yeah, it's just not putting them in one.
I know.
And it's also not giving us actually any, we're getting a standard deviation, but we're not actually getting any sort of correlation. It's not, whatever, I don't even know what that is. It's like point, and then there's like a B up in the middle, I don't even know what that number is.
Yeah, it's not giving us a correlation.
Yeah, it starts here.
Okay.
So it's not giving us one.
Should be
No.
able to, I'm just trying to figure out how we got that one, you know, you get the one chart.
We had to make that. Didn't we? It never, even in her instructions, it says it won't,
Oh,
hold on. Yeah, this should be one table, the correlation matrix. Like you have to build that. What is it looking at it like this?
Okay, well.
Nope.
Yeah, it's interesting because I think if I look at what we did the Pearson's correlation on before, we created the dummy variable and then we created the dummy variable for whether you took algebra or general math, and then we were able to correlate those two things, which could be the other ESL.
You're saying like the same with like the dual language and the mobility one.
As opposed to trying to do it with yours in the district.
Oh, okay.
We actually didn't run any correlations while our data was split. I'm reviewing all the questions. The only thing we did when we split the data was we did descriptive statistics. When we ran our correlations, we had to unsplit the data again. We didn't run any correlations
Yep,
while the data was split.
yep.
So why did we split it? Oh, to run descriptives. So I wonder if that means it was the same thing as what we got when we ran the ANOVAs.
I mean, we got what we wanted out of that.
Right.
We wanted to see the means for each year.
Right. I think what it would do for you if we split it like we just did by years and you ran a frequency now or whatever, yeah, it's just
Right.
descriptive statistics, it would give you the pre and the post means, maybe like you might want to.
Yeah, it would be interesting to run the descriptive statistics now that we've split the file.
No.
I mean, it doesn't do it in one chart. And I also have no idea what the minimum, maximum, and mean is referring to here.
You didn't ask it
Bring
for,
anything else over.
yeah, you had to bring over the other variables.
Also, I realized like when you split the file, the reason it's not in one chart is because we told it to like we told it to split it out. That's why it's splitting it out. We
Which you
said,
can do if you pull over other
Yeah,
variables.
you forgot to pull over the other stuff.
Right, not just years.
Right, pre and post.
And like this is where you could pull over gender if you wanted, or
But I'm saying that they're still going to be broken out into like a year one table, a year two table. It's not going to show you one table that has year one, year two in
Take
one.
that out. Take that out. You're saying take out the years because it's already split.
Right.
Isn't that what you're saying?
Yeah. But it'll probably still split it because it's going to show it.
Right.
Yeah. See, it's going to.
But what it does here for you, we would have constructed it the same way. But what it's giving us here is pre-post together for each year, whereas the ANOVA only gives you all pre for all 6 years and then all post for all 6 years. We would have had to reconstruct it in one way or another. Right? It's the same, like we kind of went around it. I don't know. Okay, wait. So now I wonder if you did it. So here you could do, if you wanted to see like for each year, was there significant difference between the pre and the post for kids in year one, kids in year 6? Does that matter? Is that a question anybody wants to know? Because if it is, then you would do.
That's what we've been trying to figure out, I think, is how to run a correlation between the years.
No,
and
it's not the same thing as an independent t-test. A dependent t-test. A dependent t-test is saying that the mean change in the mean. So like right here for year one, 117 students. The difference between the mean, which is 660 minus 619, that's the difference in the mean. If we want to know if that difference is significant or not, you would run a dependent samples t-test right there because it's the same group of students at 2 different points in time. You would do it.
what I was interested in.
Right. That's not the same thing as what you want to know is there a correlation
this one
between the number of years and then the number of years and their post.
Look at your 5.
So it's like, I don't know if that would make a difference. I don't know what kind of question it would answer if you looked at whether the difference in mean performance is more.
Right. Is it answering our question as to whether or not mobility matters?
I mean, they sort of answered that in the context. They said mobility does matter. They said if you move,
we would be trying to do, we would be saying, let's test and see if what happens out there happens here. And so we would expect there to be a difference. That's a regression. That's a simple regression. Just that's saying we want to predict whether your post scores matter based on your independent, which is your number of years. Like that would be a simple regression analysis. So you have one independent variable and you have one dependent variable, and you're saying, does one predict the other? I don't know enough about it other than that but I mean, I haven't, as you can tell, I haven't read that chapter, but I did watch the video.
I did read that chapter last night, but
yeah.
Okay, so number 1, we could try to run the regression if we want, or number 2, we could go over to start to try to look at the language program interventions.
I personally, looking at the time, I think I'm interested in switching because the more I dig into the mobility and all of these numbers, it's super cool. I feel like great about experimenting and exploring and everything, but I don't think I'm going to write about it because I don't think I feel confident enough about all the tests that we've run to really go into it any more than like what the context. So like, I feel like my questions are going to lean more towards the comparison of the 2 programs. and leave out the
Well,
mobility.
and I mean, I would argue to some degree that we've already, even with the ANOVA that we ran on mobility, that's one of the tests that we needed to run, one. And so you could take that ANOVA on mobility, if someone wanted to use mobility as one of the research questions, and you could say, based on this ANOVA, here's what I would do next if it was me, period, done with the assignment, right? You don't have to actually do the next.
Right.
And now that we split the file and you've got some different things by years and means and stuff like that, there's things people could pull if they wanted to write on mobility.
So you should unsplit that file, right?
Yes.
Okay.
Which is just that dot right there.
Is that what it is? Okay.
Yeah, because if you go back and you look at it, it tells you right here, analysis by groups is off. That's your current status. So now we have to figure out where which variable actually talks about
So that would go back to our context, right?
yeah.
So. Of course, they don't give us that.
It's not even a variable, is it?
What?
Uh,
Program is?
ESL or dual language?
No, it's a variable. It's called lang wait, what is it? It's called language program. No, right there, number 9.
There, language program. Okay, so dual language is 1 and ESL is 4. So if we just get started and we were to run descriptive on this,
No, in the variable itself, there's values. I think you pull it up. It's number 9.
Right, that one.
would it
And
just give us like enrollment numbers first? Like if we just want to see like how many are enrolled? If we want to do frequencies?
I think so.
And we want the language program.
Mhm.
We don't really want anything else.
Right, that's just going to tell you how many belong in which group. It should.
That's what we want to see.
Right. So you have 52 students in dual language and 53 students in ESL. It's 105 students total that were exposed to this kind of any intervention.
What the heck? That's not very many. That's for
Because
6 years. Like now I'm confused about the year. Is this like every year this is the number?
all years combined,
Yeah, this is the total number.
743 students said that English was their first language. 105 students said that English was not their first language. It's either like Spanish or Navajo.
Is that what this is telling us?
Well, that was another frequency on language. There's another
gotcha.
variable that says,
That says primary.
so I ran that one and it was just like English 743, Hispanic or Spanish 183.
Yeah, what I'm seeing on this one is there's 848 students total, and only 105 of them are enrolled in a program.
Right.
That's because those are the 105, Kelly, that said English was not their first language. This is only for students without that claim English is not their first language.
So now you'd want to know how those students did on their pre-post tests.
Right.
So you would do frequency, I think, or descriptive statistics.
Isn't that just going to show us if we just run descriptive statistics and we put those test scores in there, it's just going to show us everyone's though.
Let me see, I did it here. Do pre-post.
It's going to tell us only for those students.
think so. No, that's not the right one. Hold on.
No, to your point, Kelly, that's everybody.
Yeah, 848 students, and it's just
Do this
divided up in this giant table.
do
It's almost like we need to split the data file by. That's what we need to do. We could split the data file and group it because there's only 2 values in that group, right? And then it would show us. If I go to the data, if I split the file
Mhm.
by this
By
thing
language
right here,
program,
yeah. By that,
okay,
now
I
anything we analyze is only for those 2 groups.
okay,
Now
no,
what I run, go ahead, I'm sorry, what?
no, yeah, agreeing.
But I can also tell you another shortcut, I guess, if that's what we want to see. If you do a t-test on those 3 variables, it's going to give you the mean, the standard deviation,
Oh, that would
everything.
be perfect.
So just do an independent samples t-test.
Oh, because this is a nasty table.
Yeah,
That's just giving, those are frequencies, right? So that's why it's giving you every single value in the
Instead
frequency.
of me doing a descriptive, right?
No. You want to do an analyze. You're going to do a t-test.
Okay. I'm just curious the difference between these. I'm still figuring this out. I just want to run this because I want to see what it looks like. And then I'll do the t-test.
Same thing right there.
This is what I wanted to see.
okay, and
Did
what
you
did
split
you
it?
do there?
What's that, Kamara?
Oh, you did descriptive instead of frequency.
Yes.
And
So
that's-
frequencies
that's
is one.
that.
I kept asking that question. I'm like, what's the difference between frequency and descriptive? And now I know the descriptive gives you like the summary. The frequency pulls out the chart of like every single.
Yeah, this is what we wanted to look at. Okay,
Did you
Exactly.
split the file or no?
This is a split file right now. So
You
now
did split.
yeah, so now you're telling me to, yeah, I split the file by ESL and dual language so that I could get the 2 charts. But you're saying to run a t-test without splitting the file?
Right.
Yep.
Okay, so if I go back to the data and I go to split file and I change it back like this. Okay, now you're saying to run a t-test?
Yeah.
And that is,
Compare means. Independent. And then pick those 3. So it would be language, pre, post, and program.
well, isn't that the grouping variable? That's not the test
Yeah.
variable? Okay. So the grouping variable would be the program.
yep,
And then we have to define the groups. So group 1,
Is 1 and group 2 is 4. Remember that they said ESL was 1 or whatever. DL was 1.
yep.
and
ESL
was 4.
Also look at other things here too, right? Like what would happen if we did the years in the district?
I don't know.
Well, before I add anything else, let's just see the comparison of what this looks like to descriptive statistics, because I'm curious.
Do you have to go to options at all, or does this do it for us? Oh,
That's fine, yeah.
looks like it's good.
So you see above the top there, right there, that's the same. The only difference is that we don't get the variance here,
Mhm.
which is a little bit more description, right? That's a good way to think about it. But technically,
So then go down your independent samples t-test.
oh wait, this is different.
I mean, this is what we got at in the last assignment.
Yeah.
But if you scroll up a little bit, this table right here, group statistics, is that the same as if you built it with the other stuff you have above it?
Have to look and see. So let's just examine it. So language program dual language, the pre-test mean is 631.44. So 631 and 676, dual
Yep.
language.
No, but that's,
So if I come down here and I look at this,
Yep,
oh,
same,
yeah, it's,
yep, yep,
but what it's doing here is it's comparing, it built it together, right? Because the one that you did with the split file was just giving you pre-post for ESL, pre-post for dual language. When you do the t-test analysis, what it does is it puts it all together for you, and it says, if you're looking at pre-test, this is how dual language did, this is how ESL did. And then when you look at post-test, this is how, which to me, this is probably the one that we'll go to first. Like, this is the one that has everything that you want to look at, which is look at the means between the two groups.
and if I'm looking at this and if I'm interpreting it the way I think I'm interpreting it, and this also aligns with my hypothesis. So my hypothesis was that a dual language model would be more effective than an ESL model based on what they said, because like they said, students are exposed to intensive instruction in English. The second one is dual language includes instruction in both English and Spanish with the intent of encouraging academic proficiency in both languages. So again, me coming from my curricular background, I'm leaning towards the dual language model. When I look at these results, it actually shows that. It shows that, and again, I don't know that there's a correlation, but looking at the scores for ESL, the mean scores for ESL, both pre and post, are much lower. The pre and post scores for dual language students are much higher.
And what the t-test is saying is that the difference between the means in both the pre and in the post are significant at 0.001.
right.
And I look at the degrees of freedom, which says 103, which is correct. That just gives me a sense that I know, like, the numbers, like, because I wouldn't know if these numbers are wrong. But degrees of freedom is your total and minus 2, I think. And so that's 105 minus 2 is 103. So your T statistic is 6.725. Significant at less, P is less than. P is less than? Yeah. 0.001. That's probably the one that if you also wanted to look at like the effect size, that's the Cohen's D down there. 1.3, 1.4. I think that's like really strong. That's all I know.
So let me ask you this, could we have run? I don't want to take us down you could also run a t-test on gender here as well, right? If you wanted to see how males and females performed.
Yeah, let's do that one. And you would do it on all students, Kamara, out of the 800, or do you want to split it? Like, if you just want to say, do boys and girls, do they do better?
Right, you could do it either way, I suppose, right? You could do one that's just do boys and girls do better. And then you could do impact of these programs on boys and girls.
Right.
Is there a difference?
I
So
think
we
for
would
that,
group it on gender or female. I don't know why we split that out. Like, we created a new variable for some reason. Does gender actually,
I
I don't know if we needed to do that.
think you can use gender because it's we used, yeah.
Oh, but what were the groups? Is it MF? Like, I have to actually go, because this has to be
Oh,
exact.
otherwise just use your
Use
female.
yours.
Just
Yeah.
use the female. Cause then you know.
Yeah. Oh,
I still don't, it's one is,
1 is 1 and 0, and group 2 is 0. Those are correct numbers, by the way. 409 are females. So this is saying
girls did better. That's what it's saying.
girls only did better. Girls only did better in the pre-test. It was not significant in the post-test.
They did better in the post.
I just
Not
get, but I see what you're saying. It's not as significant in the post as it was in the.
Not
It's
a
not-
significant difference in the post.
It's not a significant difference, meaning it could be left to chance. It could be other reasons why there's that difference, right?
Yep.
Which I don't know what you do with that, but
Nothing. I mean, you're not gonna like,
I think so, and I think that's what you'd write it up. You'd write, like, if you chose this as one of your tests, right? You could just simply write it up to say, gender does not seem to be a factor in performance on the tests.
overall.
Overall, there's not a significant difference in performance on post-test based on gender. So we don't have to, like, I'll say it this way, you don't have to come up with an intervention for the boys or the girls separately different, right? There's something else other than gender at play in terms of the difference.
except for the fact that the girls come in higher at the beginning and then, so you could argue that that the boys are growing more
You could.
because if you look at
Absolutely, but
the
because then in
boys,
post, you no longer have a significant difference, right?
yeah, if you're comparing boys pre-test to boys post-test versus girls pre-test to girls post-test, the increase for boys by being in school. So again, I'd argue like the summer is a better experience for the girls. Not being in school, better experience for the girls.
Okay, so now
Okay, well, what else?
could you run a t-test on?
You want to see the boys and girls in the language programs, don't you,
Yeah,
Kumar?
that's what I wanna see, right?
So I think in that case, what we would do is we would split the file.
You would?
You
I
wouldn't
think
just
so.
do, you wouldn't just do this to
So
see,
this is, oh, wait,
Yeah. Try that.
but what language program are you talking about? This is all of them.
This is all the
100.
language programs. Yep.
So you would have to, is that what you wanted? Oh, I see what you're saying. So of all of the students whose first language is not English, is there a difference between boys and girls? And the answer is no. Statistically significant difference.
Nope.
Right.
but you could go further and say now how many girls are enrolled in, which might need to split the file then, because you would want to see how many girls are enrolled in ESL versus how many girls are enrolled in the dual language one. But if overall there's not much of a difference,
There's no reason to go further down, right?
Oh, well,
I mean,
Right.
it could be if you wanted to argue that
Or
if
you
we found that there was a statistically significant percentage of girls were enrolled in one versus the other, and combining that with the realization that the girls are not making as much of a gain, you might make a conclusion that whatever program the girls are enrolled in, if it is statistically higher of one versus the other, that program might not be as effective. I think you could say that, right? But that's only if you run that test and you show, again, like it says 52 girls are enrolled in a language program. If 40 of them were enrolled in the ESL and 10 were enrolled in dual language, coupled with that test that we ran, that we can show that their growth, their gain is less than the males. Like, is there a correlation there to like what program they were enrolled in? Does that make sense?
Something's really weird though, because 52 and 53 is the same number breakdown between ESL and DL. Is that coincidence?
Well, it's the total number, right? There should be 105 students.
Yeah, but I'm just saying the breakdown is so weird. It's 52, 53, and the other one is 52, 53. In terms of, if you looked at language program breakdown of all students, it's
Oh.
52.
Yeah.
That's why I think it's
So
weird.
now I'm curious, like,
So we may not be looking at female male is what you're saying, Sandra.
How about this? Go, Cal, if you can go to analyze, descriptive, crosstab. Pick gender and program. Language, gender, gender and primary language. So gender and, or wait, no, yours, female. Yeah,
Or the
just do that.
row or the column.
Doesn't matter. It's just a 2x2. And
Okay,
then primary language is the other one. Well, no, sorry, language program.
Okay.
And then just see what that looks like. There it is. Yeah, it is. It's 52, 53, just coincidence. So there are more. It's pretty
Yeah.
split,
You made that, they made it split. Yeah.
tricky.
so what I was saying was doesn't apply. But if
Right.
we looked at it and it was like 40-10,
Right.
I'd argue to like explore it more, but since it's roughly equal.
Okay,
it's rough.
so now, have we looked at how these kiddos do compared to the kids who haven't taken either of these programs?
No.
Okay, so for that, you want to find students whose English
Was
Who's-
not the primary.
and who are not enrolled. I don't know what number that is. How would you find that? So you would do, maybe you could do a crosstab here, another one, just to see what's the N. So you would say,
There's a primary language.
that one. See what happens with that.
Well, this is just going to tell you who's enrolled.
It should show zeros. So if your primary language is English, it's going to show zeros for you there. No, that's not right.
Right, so it basically showed us that what we knew before.
Yeah.
What? Oh, yeah.
12% of the kids were enrolled.
Wouldn't we want to do one of those things, maybe not by splitting the data file, but where we group by and we group by primary language and the grouping variables for primary language? Cassandra, you're saying if their primary language is English, they're not enrolled. Oh, there's three primary. There's three.
All right, there's English, Spanish, and Navajo.
Mhm.
So maybe you would, oh,
So would we have to do an ANOVA then to do that? Since it's more than two?
yeah, maybe. I think so. We're saying that we want to see the pre-post. No, that's not what Kamara wants to know. We're making an assumption.
I
Right.
want to know the post scores of those whose primary language is English versus the post scores of those whose primary language is not English.
Oh, I thought you were asking something else.
No,
I thought you were.
I got that. I just, because there's three values. If it was only two, if it was just English and Spanish, it would be easier. The fact that there's three values, I'm like, okay, do I run? Because I know I can't run just this.
But you could recode 2 and 4 to equal 2.
Exactly.
Okay. So if we create, so wait a minute, which one was that again? That was primary language. So
Mhm.
we want to do data. Oh, wait a minute, transform, recode into different variables.
Mhm.
And we're going to do primary language into,
Just
what do we
language.
just,
Language.
language. And the old and new values. So the old value of, I have to remove all these.
So 1 is 1, 2 is 2.
And 4
is-
is 2.
And 4 is 2. Mhm.
And so, yeah, what this is just telling us is English versus non-English.
Mhm.
So then if we want to do this now, we want to run,
T-test, right?
An independent t-test. Comparement, yeah.
And our grouping variable is going to be this.
And the test is, wait, the test up there is post.
Post.
What is confusing to me right now is that it's saying, oh, okay, so it's saying 226 are non.
Right.
Yeah,
because-
that's correct.
Right, because only 105 of those 226 enrolled in a program.
Which is the question I thought you were asking.
I know,
tomorrow.
I kind of was.
Okay, but that's fine. So this is a really cool one, and it does say that there is a difference, which is what we would expect, right?
There's a statistically significant difference in the test between those for whom English is their primary language.
So let's run the one you wanted to run. So how do we do that?
You would have to find out of those 226 students, how many of them are not enrolled in a program? And I don't know how to do that. You'd have to look at,
Well, I really want to take the ones enrolled in a program and compare them to everybody else.
which is this? Oh, no, that's not this. This is different.
So you could do a t-test again, right? Because it's just two groups.
You would have to make up.
And you would take those in a language program and the post-test, right?
So language program,
Well, wait. What are the variables in a language program? Because
1 or 4, 1 being ESL, 4 being the dual language model. There isn't a variable for all students and those not enrolled. So we couldn't group it this way. It's going to just divide out those that are in a language program. We'd have to create our own variable, I think, to code in a program versus not in a program. I don't think that that's a variable we have.
I wonder if you can make it like, so if we made it a variable, the first value would be all English. No. So your N is 226.
That's all right. I don't know that we need to do this. We probably.
Yeah, I don't know if you need to do it right now, but because I mean, it's a good question. It's like out of your 226, you want to compare the 105 with the
Right,
20.
because in essence, you want to be able to say whether or not you think being enrolled in one of those programs is worthwhile or not. And I'm not sure that what we've done so far, we could say that with confidence.
I agree. But what you could say is outside of all the other people, you could show the difference between the two programs and say those enrolled in the dual language program showed this as a post score. Those enrolled in ESL showed this as a post score. So you could potentially show a differential value between the two programs themselves.
Right.
Yeah.
And if you wanted to throw the other things in there, like gender and everything else, you could be like, gender is not a factor or whatever, like we did on our other homework assignment.
Okay. So, TEL, will you share your output file?
Yep.
And then, I mean, do we all think we've got enough here to work with? Not that we can't reach out to each other as we're starting to write it up, but
I'm good.
I think that's a lot. That's good.
Yeah, there's plenty in here for us to
I mean,
do.
there's plenty in here considering we only had to run either a t-test or an ANOVA or a right, and we've done multiple. So I think whatever direction any of us wants to go,
Yeah.
I think it's here. And
Thanks for calling us in tomorrow.
I'm saying this to myself, like as curious as I might be, it has zero relevance to actually getting this assignment done, so who cares? Right?
That's the hard part, because now you started and I'm like, let's think about that.
I know, but it just doesn't matter, like, it's like, okay, well, it would matter if I was an administrator in this district.
But
I
not
would
today,
care.
not today.
Certainly
Not
not.
even Kyle today is an administrator right now. He is just a guest in your house doing a homework assignment.
None of us are administrators today.
I uploaded the file to our Slack, but I'll also send an email to Dan and Kyle if you want that output file too. But it sounds like Kyle's probably got his output file maybe, but it'll have everything. So
Yeah,
I
why
would
don't
love
you
that.
send it just in
Thank you.
case, he's been plugging along, I have not.
I don't know if I got it all though.
the other
Have-
thing you might want to is because this data file has changed. Because I added so if you want to keep playing with this data file, I really should save it as well. This Cactus Middle School data final assignment, I'm just gonna put V2 for version 2. In case you decide you want to go back in and manipulate the data and you're not starting with just that one, and you can see because we've got, I think we actually put three different variables in there, and that's one of the potential assignment requests, is that if you create a new variable, talk about it and why and blah blah blah. So
What was the language one that you did?
we tried to do a language one where we tried to split it to where it was English versus non-English, because we were
Primary language,
Oh yeah.
Because there was Spanish and Navajo.
yeah.
Okay.
All right, well, I will tell you this, I'm going to work on this today while it is still fresh in my head, so if anyone has any questions along the way,
Same here.
feel free to reach out, and or I may do the same.